Hi, all. So, now we can discuss this new session, heating and cooling load calculation using HAP software. HAP software by Carrier Corporation. Okay. So, heating and cooling load calculation using hourly analysis program. Why that is hourly analysis program? We can discuss that. See, multiple times we have discussed in the previous session, if we need to propose air conditioning machine inside the space, whether that is a cooling device or a heating device, first thing, suppose if it's a cooling device, first things we have to calculate from what all sources the heat is entering into the space and how much it is. Accordingly, we can propose your air conditioning machine. See, the market, suppose if you are going to purchase an air conditioning machine from a shop, they might be like following some thumb rule. They'll be saying that, okay, what is your room area? 120 square feet, 1 ton. 140 square feet, 1 ton. Means like, for example, I'm having a bedroom of 5 meter by 4 meter. What's the floor area? Floor area will be like a 20 meter square, 5 by 4. 20 meter square will be how much square feet? 20 meter square into 10.765. You can convert that into square feet. 20 meter square is approximately 200 square feet only, but accurately 20 into 10.765, you can convert that into square feet. Correct. 215.3 square feet. Suppose normally, especially in India, non-insulated building, 140 square feet, you can consider 1 ton of refrigeration. Means each 140 square feet of floor area, we can consider 1 ton. But if the glass area, side wall glass area, everything is small, 120 or 100 to 120 square feet, we can consider 1 ton. Normal residential building, 140 is more than fine. So your ton of refrigeration will be 215.3 divided by 140. 140 square feet, 1 ton. So this value divided by 140, how much ton it is? 1.53 tons of refrigeration. Correct. 1.53 tons of refrigeration. That should be your cooling capacity. But if it's a ductable machine, airflow rate we should find. Airflow rate. Normally, 1 ton of refrigeration, 350 to 400 CFM of airflow rate can come. Normally, everywhere we will be considering 400 CFM per ton of refrigeration. So 1.53 into 400 CFM, airflow rate also we can calculate. With respect to that airflow rate, duct sizing, air terminal selection, even ESP calculation also we can propose. But these kind of thumb rule methods are not proper. No, it is not optimized way of design. In the basic classes, I told if you are oversizing your AC machine or you are undersizing your AC machine, both will create trouble. The machine life will be decreasing at the same time. Electricity cost will also increase. So that's why optimized way of design, you have to calculate it. You should not oversize. So thumb rule, most of the time that is, we don't want this 140 square feet, 1 ton always. Even if the number of people are more in office area and all, sometimes we don't want even 160 square feet or so. Most of the offices like between 2 ton to 280 square feet only will be getting 1 ton of refrigeration. So this is slightly oversizing. So your AC capacity will be increasing. Your compressor electricity consumption will be increasing. Okay, that's why. But this is just a thumb rule for your knowledge, I told. Okay. See, if you want to perform the heating and the cooling load calculation, we can do a project now. I will take a project and I will explain. Before starting the project, prerequisite, prior to starting your job, what all documents or what all things we need to collect? Okay, what all things we need before starting our heating and cooling load calculation? What all things we need? The first thing, we need drawings. Correct. Drawings, two-dimensional drawings are more than 5. We don't want 3D. From where we will get it? We'll be getting from the architect. If you're working in a consulting company, architect only will be preparing their first drawing. So from the architect only we'll be getting it. But there is also what drawings we need. The first one, we need floor plan and furniture layouts. Floor plan and furniture layout. Sometimes it might be a single layout, or sometimes it might be separate. Floor plan will be separate, furnitures will be separate. Why that is? Because if you need to do the heating and the cooling load calculation, you have to calculate the area first. Without knowing the area, how we can perform it? Also, if you want to calculate the people heat gain, yes, people heat gain, if you want to calculate, suppose if you are having furniture layout, table or chair numbers we can count. Accordingly, we can calculate the number of people, because people will be also ejecting sensible heat and latent heat. So from the furniture layout, a table number, chair number, we can count. Yes, if you are not having the furniture layout, we can go to ASHRAE 62.1 standard or ASHRAE 62 ventilation standard. As per the occupant density, there is a term called occupant density. By using that occupant density, the number of people we can calculate if you are not having the furniture layout. Okay, but if you're having the furniture layout, we have to follow that. So this floor plan and furniture layout is mandatory to perform your design. The second one, it is not mandatory. If you're getting if you want to perform your calculation accurately, this is mandatory. Even if we will be discussing both, if you are having the detail or we are not having the detail, how we can sustain. But we have to sustain in the market, right? We have to perform activity in your company. Okay. The next one, we need sectional elevation details. Elevations and sectional details. Why? Floor area is two-dimensional, right? Suppose if you want to calculate the volume of your space, we need elevation, sections. Elevations we need, height, correct. Or if you want to calculate how much wall area is exposing to the atmosphere. So the length of wall multiplied by height of wall, you can find the wall area. So if you want to calculate the building objects, wall, window, door, partition wall, if you want to calculate the area of those things, definitely we need elevations. Or when we are performing a term called infiltration calculation, building height is also mandatory to calculate the volume, because volume of space is mandatory to calculate infiltration. Okay. Sectional details is also mandatory to find or to propose the AC machine. For example, when we are placing our heating and cooling load calculation, sectional details are not extremely mandatory. But even though sometimes within the spaces, ceiling will be not uniform. Plain ceiling will be there, stepped ceiling will come. Means the height of ceiling will not be uniform everywhere inside the space. It will be like suppose if this is your building, your space ceiling this is your false ceiling level, this is your finished floor level, this is your false ceiling level. So ceiling will be not uniform, it will be like a stepped one or a curvy one. That's why if you want to calculate the average ceiling height, there is a term called average ceiling height in HAP. So we need sectional details as well. Okay. The third one, we need RCP, means reflected ceiling plan. How the ceiling, your false ceiling look like. In your reflected ceiling plan, you will be having the location of diffusers, approximate location of diffusers. You'll be having the location of light fittings, what type of ceiling it is, whether that is a plain ceiling or if it is a grid ceiling, those details we'll be having in the reflected ceiling plan, RCP. RCP is mandatory to propose AC machine. After the heating and the cooling load calculation, we can propose ductless machine, at the same time we can propose ducted machine. On the false ceiling, if the architect has shown any type of air terminals, means whether that is a square type air terminal or a round type air terminal or a linear bar grill or linear slot diffuser. To provide airflow rate through all these air terminals, we have to propose ducted unit. Okay, that's why whether ducted unit has to be proposed or non-ducted machine has to be proposed, reflected ceiling plan is required. Okay, so these three details are sufficient for time being. Drawings, floor plan, furniture layout, elevations and sectional details, a reflected ceiling plan. Fine. The next one, we should gather a location of your space. Location and function of your space. Of building. Building and spaces means location, because if you want to calculate the solar heat gain, the sun heat gain or the solar radiation that is hitting on every direction is not uniform. Sometimes it might be more in west direction or northwest direction. So that's why orientation or the location, function and orientation of building is also mandatory. Location, function and orientation of building is also mandatory. Why location? Location means like, for example, if you are doing a heating and cooling load calculation in Trivandrum. So the climate details of Trivandrum we should take, right? Or you might be doing the same in Delhi, or you might be doing the same in other European countries, or if it is GCC. As per the location only, we can like take weather details. As per that weather details, we can perform our design. That's why location of space is mandatory, or the building is mandatory. The next one, function of building and function of spaces within the building. Function of the entire building is uniform, then okay, that is only one you can select it. But within the building, multiple spaces will be there. Spaces means rooms. Architecture terms is called a room. MEP point of view, we used to call that as spaces. So what activity they are performing? Because the heat ejected by people is not uniform. For example, if you are designing a gymnasium, the level of activity the people will be performing will be different comparing to a library. Also, the electrical equipment demand or the load demand within the gymnasium is like higher than the library or classroom. That's why function of space is mandatory to know. Correct. To perform our design. Then orientation. Orientation means direction. Direction of building is mandatory. Sometimes in the drawing somewhere they will be marking the north direction. Accordingly, we can do it. They will give you only one direction, north direction. Sometimes like this or sometimes like this. If you're getting the north direction, other direction you should find. Okay. How much directions we are having? 4. Correct. But overall, we are having 16 directions. 16 directions, I will explain. Okay. The third one, we should find the U values of building. U values we can discuss. U values of building materials or building structure. No, means U value of materials means wall material. Okay. You'll be having wall material, floor material, roof material, door, window, ceiling, partition wall. Then we will be having like a skylight, shades, a lot of details are. So U value is called overall heat transfer coefficient. I will explain that when we are giving input for walls. Okay. So all these things we have to collect, then we have to do it. Drawings anyhow you'll be getting from the architect, whether it's a new project or if it is a maintenance project or if it is a fit out projects. These details definitely we'll be getting from other things. U value anyhow you are not going to get from the architect because it's a technical term. But you will be getting the wall details or what material they are using for wall construction, floor construction, roof construction. The material details you will be getting from the architect. Architect will give you that material details. So if you are getting the material details, how to arrive the U values that we can study. We have to calculate that. But if you are doing a fit out project, suppose if you are doing any fit out activity in a Dubai mall, there is a tenant manual. So within the tenant manual, it's a kind of specification. Within that tenant manual, the Dubai mall authority will give you, these are the U values you should perform. So accordingly, you can do that. If you're not receiving it, standard U values are there. We can follow that from ASHRAE. Handbooks, we can take it, or ASHRAE 90.1 handbook, we can take it. Different sources we are having to find the U values of material. Anyhow, these are the prerequisites. Prior to start your heating and cooling load calculation, these things you have to gather, then only you can do it. Okay. See, I'll be taking a project. This one. It's a fit-out project. And see, a lot of spaces we are having. It's a floor plan only. It's a floor plan. Multiple spaces we are having within this floor plan. For example, here you can see we are having a training room 1 here. Training room 1. Then if you are going here, we are having training room 2. Okay. Then an IT server room. Here we are having a discussion room. A discussion room 2. Discussion room 3. Okay. Training room 3, 4. Here we are having a pantry. Then a ladies' toilet. A gents' toilet. Then we are having lift elevators. We are having a lift lobby. Stair area. Actually, this is a G+4 building. Sometimes in drawings, they might be marking like a G+, like B1 plus, B2 plus, G plus, M plus, 1 plus, 2 plus, 3 to 6 plus, then LR plus, RF plus, or lower roof, upper roof. Okay. LR plus RF. Means in the drawing title, the building floor details, they'll be marking like this. What is it? B means normally basement. It's a building. It's having 2 basements. It's a ground level. Basement 2, basement 1. Then it is having a ground floor. So it is ground floor. A floor within the floor is called mezzanine floor. M means mezzanine only. A floor within the floor is called mezzanine floor. This is called mezzanine floor. You can see this is a main floor, right? Main floor height from the finished floor level to bottom, this much will come. But within that, you can see there is an alternative for this floor. This is called mezzanine floor. So that's why G plus M means within ground floor, we'll be having a mezzanine floor. Then above that, we'll be having like first floor, second floor. Then 3 to 6 together, if they're providing, means these are typical. 1 is separate, 2 is separate, then 3, 4, 5. 3, 4, 5, 6 means these are typical floor only. Typical means same. 3rd floor to 6th floor, the floor furniture layout, MEP services, everything remains same. LR means normally after 6 we'll be having a roof only, but they'll be marking as lower roof and upper roof. Sometimes above the roof we might be having a floor. Above the roof we might be having a floor. This floor is called penthouse. For example, if you are having a swimming pool somewhere here, a floor above the roof is called a penthouse. So this penthouse roof, sometimes they will be marking as upper roof. Or at the same time, this stair area or lift elevator area, headroom, top side headroom, they will be projecting beyond the roof level. Above that headroom only, sometimes we might be placing our water tank and all. Then they will be marking that as UR, upper roof. So lower roof can come, upper roof can come. Penthouse. Penthouse means the floor above the roof. That is called penthouse. This one. On the roof side, no, might be having floor. This is called penthouse floor. Topmost floor. Clear. Just for it. Okay. See what I'm doing now. I'll be doing the heating and the cooling load calculation of this building. This building we'll be doing, because we are just starting now, heating and the cooling load calculation. In the upcoming classes, we'll be studying all the design. And we will be implementing all the design in this project only. We have to finalize this project, G+5. Okay. Okay, we can start. Actually, this is first floor. This is first floor only. Initially, I'll be starting with this training room. Before going to open this heating and cooling load, sorry, this HAP software, building drawings, you should identify, right? So as you know, this is my floor plan only. Because the floor area I can calculate using the same plan. At the same time, furniture is also there. Correct. So it's a floor combination of floor plan plus furniture. And see, what is this? If you're going to the drawing, you can see this kind of hatched thing. Hatched thing, this one. Actually, this double hatched lines are representing the brick wall. But one thing, if you want to get the perfect details of building materials or the building structure, you have to go to ID, means architectural ID drawings, architectural ID, interior design layout, separate detailed layout they will provide. Means each drawing, ID drawings in material detail drawing, they'll be marking, they'll be clouding this, or each material they'll be marking like some number. This is like, okay, wall 1, or this will be wall 2, this will be wall 3, this will be window 1. They'll be marking in the drawing that what is this window 1, what is this wall 2, like that. Separated drawings they will provide. In that drawing, in-depth details of material they will provide. Who will provide? Architect. Normally in the architectural interior design drawing, ID layout, we will be having the material details. But generally, normally, this double hatched lines will be representing which one? Brick wall only. Brick wall. Okay. And then this one, this dark, if you are taking the printout of this one to the PDF, floor, it's actually the same floor plan only. You can see the same pan, this one, double hatched. Near to that, you can see the continuous dark thing, this black color. This one. Actually, there is RCC only. Reinforced cement concrete structure. R6. Reinforced cement concrete structure. And you can see this one, the double line, you can see this one means it is coming like this. Middle line, you can see that one line, or 2, 3 line, this one. Actually, this is a glass window. Glass window. Anywhere, like if you're finding like this in the middle 2, 3 lines, these are called a glass window. Okay. The number of glass panels are increasing. Accordingly, the lines will increase. This is like a 2 panel now. 2 panel only means 2 glass panels will be joined together like that. So number of panels are increasing, that will also increase. Okay. These are glass only. So these double hatched lines are brick wall. These are RCC. Then in between this training room 1 and the training room 2. This one means middle line, you can see this one. Sometimes this also they will be marking like this, hatching like this. Actually, this is your partition wall. In between 2 spaces. This is not double hatched line. So it's not brick wall. Actually, this is partition wall. Partition normally, which material we are using? Gypsum only we are using. Gypsum partition wall. Gypsum partition wall means middle side. This one. Middle side, you'll be having this metal frame or stud, we used to call that. Middle side. Then inside and outside, we'll be proposing this plaster of Paris, gypsum. So plastering cost you can avoid there. After applying putty and all, you can do the painting on the surface of this plaster. But it is moisture. It's not moisture resistant. So bottom level, through this floor level and all, sometimes the material is not perfect. This kind of the material will erode after some time because it is not moisture resistant. Okay, so that is this one is which one? This partition wall. Fine. Okay, then what is this one? This one is stair only. Stair. The stair area means from ground floor, you can walk through this way. Through the stair area, you'll be reaching here. Okay. In front of the stair area, this is called a stair lobby. Stair lobby. In front of elevator or lift, that is called lift lobby area. Through the stair, you'll be reaching to the stair lobby. From the stair lobby, you'll be reaching to the corridor. Then you'll be entering into the spaces. Just behind the IT server room, you can see this one. This cross marked region. We are having one number there. Not only there, here we are having that. This one, this one, this one. Correct. What is that? That is called different names in different countries. Different names we are having. See, this one is called building shaft or building duct or OTS. Not HVAC duct, building duct. Building shaft is simply nothing. It is just a continuous region from top to bottom. It's a high-rise building. Building shaft will be open. For example, this is my ground floor, first floor, second floor, third floor, fourth one, fifth and roof. For example, if you're having a water tank in the top side, or if you're having an air handling unit on the top side, in between, we are not having any restriction of slab. Services we can take through the shaft, then through this, we can take the services inside the spaces. So shaft is a continuous region from top to bottom. Through the shaft, it is not mandatory to become top to bottom. Sometimes it might be extending from roof to third. Then from the roof, we will be having another shaft in another location. Like the shaft location might be changing, but majority, like 90% of time, shaft will be continuous from top to bottom. So through the shaft only we'll be taking the services. What about the top side of shaft? This top, sometimes the AC outdoor unit, if the shaft is a large space, AC outdoor unit and all we can place within the shaft. But that is not recommended much, because always the AC outdoor unit should get proper temperature atmospheric air. Since if you are placing all the AC outdoor unit, all the AC condenser will be ejecting heat within the this one, shaft, building shaft. So inside the shaft, the temperature will increase higher than the atmosphere. So that will affect the performance of your air conditioning machine. But even though, like if it is open to the atmosphere, that is called OTS, open to sky region. OTS means open to sky. So top side of shaft is open to the atmosphere, then the rainwater will be entering inside, right? So all the equipments, outdoor unit, normally, if the rainwater is hitting on the surface of this AC machine, what is going to happen? These are IP protected equipments only we are proposing on the roof side. What is IP protected? Ingress protected. Ingress protected. IP is having separate number. Means when the manufacturer is making their machine, IP specifications are there. It's a standard agency. So as per the IP rated specification, if the manufacturer is constructing their or manufacturing their equipments, the IP certification they will get. Means moisture resistant. Water will not enter into the equipment center. So your durability of your equipments, not only for AC machine, all the machine. IP means ingress protection. You can go IP number, IP 100 is there. IP 100. P100. Okay, no problem. Ingress protection. Separate table is there actually. IP, if you are going to, those guys there have IP code. IP is having different number. Each number, for example, IP 100 different names we are having for IP. Correct. IP 20 is this is NEMA, Electrical National Electrical Manufacturing Association. IP 64. What is that? So you have to go to the corresponding standard. Then what is IP 54? What is IP 100? Okay. IP ingress protection. Like moisture resistant. IP rating IP 67 or 68. You can go to that. Means from IP table you can go and you can find what is the rating of this IP moist ingress protection IP rating and all. This IP 100. IP 100, IP 66 is waterproof. IP 100 also. Different numbers are there. Okay. So anyhow, just for your knowledge, when we are proposing an AC machine within this shaft and all, that is ingress protected, good equipments only will be put. Okay. So building shaft is simply nothing. It's a continuous region from top to bottom. Building shaft, building. Correct. This one. So you can see there is a lot of outdoor unit. This is window AC only, but even though this is window and this is like a split AC outdoor unit, they are placing within the where this one shaft. Within the shaft, if we are not having proper air circulation, at the top of shaft, in the top side in the roof, we can propose an exhaust fan. Accordingly, the air circulation will be improved. Okay. So this shaft area is open to sky. Then that is called the OTS region. Sometimes in the top side of shaft, we will be closing by the help of a dog house. Means in the roof side, we'll be taking this shaft in the roof side. This is roof only, no roof. This is your shaft. This is your roof. Shaft will be slightly extending beyond the roof level. Then we'll be providing a covering like this. Services and all we can take through this way. Our side will be open, but rainwater will not be entering into the. Means we'll be providing an enclosure. Enclosure might be like a metal enclosure, like a shed you can provide, or will be masonry construction we will be providing it. That masonry construction, normally we used to call that as dog house. Means the covering that we are providing in the top side of shaft is called an enclosure, or masonry construction we can call that as dog house. Okay. Fine. Anyhow, this is our building shaft only. Why it is important? Because inside the shaft, if we are not providing air conditioning, through the shaft, the partition heat transfer will be entering into the rooms. So that we should consider. And as per the location of shaft only, we are routing the services and all. Correct. So shaft location is mandatory. And so that is our building shaft. Then what about this one? Just outside of this training room. This is not hatched one. But it is coming like section. The first, this one, this one, this one. These are panels only. What panels? Actually, this is curtain wall. This is not brick wall. For this project, we are having curtain wall in the outside. And remaining this region, we are having what wall? RCs, reinforced cement concrete. Okay. That is our curtain wall. Curtain wall is like a glass, type of glass material only. Normally for conventional brick wall or concrete wall, it is opaque material only. So the heat transfer through those wall will be like, or roof will be like what? If it is opaque, only conduction and convection. Transmission heat gain only will happen. But if it is a curtain wall or it's a window material, it is not opaque, it is transparent only. So since it is transparent, the visible transmittance or visible light will be entering inside. Whenever the light rays are entering inside, it is electromagnetic radiation only. That's if you're having a curtain wall, we can't consider that curtain wall within the HAP as a normal wall. We have to, the input will be slightly different. That's why intentionally I have taken this as curtain wall. Okay. So through the curtain wall, all the type of heat transfer like conduction, convection, and radiation has to be considered. Anyhow, curtain wall, it is not a single material. 2 or 3 layer will come. In between the layer, they will be filling like inert gases and all to prevent the heat transfer. Even if we are proposing this inert gases and all, visible light rays are entering inside. If you are proposing inert gases like argon, krypton and all, okay, that will be acting like a thermal insulation material. It will be preventing conduction and conduction heat transfer up to a certain extent. But radiation heat transfer, it is not possible to prevent by normal thermal insulation material. The visible rays are entering inside, that is electromagnetic radiation only. Radiation heat transfer should be considered. How we can prevent radiation heat transfer? Definitely we can propose some sun film we can propose. Curtain, shades we can propose. Accordingly, the visible Light that is entering inside, we can provide. We can prevent. Okay, anyhow, we can discuss that. Okay. So these are the building material normally we are having there. Understood. So why they are hatching this area? Actually, this is a fit out project only. The project name, it was our project only. When I'm sharing that with you, you can find the project name. It's a GCC project. See this hatched area. If you are going to the file, you can find. Hatched area portions is not under the scope of the fit out contract. Actually, it's a fit out project. But anyhow, we will not be in our scope. When we are doing this project, only one floor were there in our scope. But if you are doing, when we are doing that in class, the entire floor I am planning to do for your batch from the G+5. Every floor we are planning to do. It may take some time, but it's good for your career. Okay. So that's why these hatched portions, if somebody is hatching something in the drawing, there should be a reason. They'll be providing in the drawing note what is the reason behind it. So here the hatched portions is not under our scope, means we don't want to do anything there. No services we have to introduce. No services we have to introduce. That's why they are hatching it. Okay. Fine. Now what I'm doing, more details regarding this we can discuss when we are doing the input of this HAP. I'm selecting the HAP software, hourly analysis program. Installation after the session I will explain. It's like simple tool. It's not a complicated one. How much effectively you are giving the input, accordingly you will be getting the output. Okay. Fine. We can start a project. In between the tools we can discuss. See, it is actually normally two sections. Top side, weather, spaces, systems. These are the plants and buildings are also there, but these are not useful. Plus project library. Project library means below the project library, you can see we are having schedules, walls, roof, window. So type of walls, their U values, the roofs, window, that everything we can create first. Then we can go to the project. That is one method. Or you can start your project. When you are giving input for walls, input for roof, at that time we can create walls, roof, all the material. Then we can. Both the way. Means after creating the project library, you can start inputting weather, space and systems. Or when we are doing input for this weather, spaces and system, at that time also you can give the input for this. Okay. Anyhow, to start your new project, first thing what you have to do, you have to go to the project. You can start a new project. Okay. Or you can click here. You can start a new project. If previous project, already you were doing a previous project, if you want to open that, you can go to the project, you can open it. Or here also you can open that. Same like other softwares. I'm starting my new project. I'm just going to the project session, new, or I can click here. When you're selecting the project new, you'll be getting two options. You'll be getting a preference tab there. You'll be getting a tab called preference tab. In preference tab, we are having two sub-tabs. General and project. First, you can go to the general. Unit you can check. Unit, English and SI metrics. So if you want to do area in square feet, the final AC capacity in ton of refrigeration, airflow rate in CFM, then you can go for English. But area, everything will be in square feet. If you want to do SI metric, means if area should be in meter square, airflow rate in liter per second, then you can select your SI metric. I'll be selecting SI metric. See, under the operating mode, energy analysis features, you can check or you can uncheck. Both are not having important role in our report generation, but select it. Enable energy analysis features. You can select for time being. When we are doing the scheduling and assigning the scheduling, I will explain once again this one. What is the importance of this energy analysis? Okay. Now, after selecting your unit, you can come to the project. Ventilation, energy standard, lead currency unit. What is your ventilation standard? I'm using HAP 4.9. Updated versions, we might be having updated standard as well. But base values of ventilations are having no change. Okay. So ventilation standard ASHRAE 62.1, but updated one you can assign. I'll be assigning this one. Energy standard ASHRAE 90.1, updated one you can assign. Lead rating is for leadership in energy environmental design. That is for green building analysis concept. We're not doing that. Currency unit, by the help of HAP software, simulation is also possible. Means if you're having an air conditioning machine, as per the schedule that we are assigning, 1 year, if that AC machine for working, then continuously working, or with respect to the working hours, how much electricity cost it can come, that process is also possible in this by the help of HAP software. But unfortunately, that is not accurate because it is not considering any energy efficiency ratio and all. That's why this green building or cost consideration for currency and all, that is not good for this. Okay. Anyway, select this ventilation standard and energy standard, click OK. Now we have assigned your units. We can save because now the project name is untitled. I am saving this one. You can click here. You can save it. I am saving this like a, okay, or HAP project. HAP project. Okay, that is save. Okay. The next step, now you can see the name came as HAP Project GCC. The next step, you have to assign the weather details. Weather details means which location it is, you can find to this one. Now, we'll be doing this project in where Abu Dhabi only. This one is in Abu Dhabi. Okay. So that's why you have to assign the weather location. So select the weather. Now you can come to the weather property. Double click and open it. You can see we are having under the weather properties, design parameters, design temperature, design solar, simulation. Okay. So first I'm just going to the design parameter. If you want to do your project, what you have to do? The region, location, and city you have to assign. Okay. So the region, you can select Abu Dhabi, you can select Middle East. Location, UAE, United Arab Emirates. City, Abu Dhabi. Abu Dhabi, we are having 6 or 7 Emirates, right? Sorry, UAE. But only Abu Dhabi and Dubai is there. What about other spaces? No problem. Any space you can select under the city. We can change this. Okay. But when I am selecting this, you are getting summer design dry bulb temperature 43.9. Winter design dry bulb temperature 11.1. This one, the software will be using for cooling load calculation, summer air conditioning system. This one, the software will be calculating for cooling load, heating load calculation in winter air conditioning. Okay, anyhow, we can discuss these terms. The first one, latitude and longitude. Why that latitude and longitude is important? Latitude and longitude is important because with respect to the latitude and longitude, the solar radiation value will be, or solar heat that we are getting from the sun will vary. Oh, okay. Fine. So this is our Earth. I'm very bad in this making these drawings and all, but somewhat explanation. So Earth. So these vertical lines are called longitude. This is called latitude. Correct. Top side we are having positive, then we are having negative values. Correct. Actually, this is equator. Above we are having positive, below we are having negative. So actually, latitude is 24.4 degrees Celsius. Okay. Longitude is minus 54.7 with respect to the reference, that is minus 54.7. So as per this latitude and longitude, you can mark your this point, Abu Dhabi point on the globe. Accordingly, the solar radiation will vary. With respect to this latitude and longitude, what is the solar radiation from the design solar we can get? So this value has arrived with respect to this latitude and longitude. Elevation. What is elevation? With respect to the sea surface. Okay. With respect to the sea surface. On what height the point is? Elevation means Abu Dhabi will be like a 26.8 meter with respect to the sea surface level elevation. Okay. Now this one, summer design dry bulb temperature, summer coincident average wet bulb temperature, means when the atmospheric dry bulb temperature is 43.9, what might be the wet bulb temperature on that scenario? 23.3. Coincident wet bulb temperature. Summer daily range means on a peak sunny day, the maximum temperature within 24 hours will be 43.9. Minimum temperature on the same day within 24 hours will be like a 33.9. So 43.9 minus 33.9, you'll be getting 10 degrees Celsius or 10 degree Kelvin, whatever it may. You're adding 273.15 plus 273.15. When you're taking the differential, you'll be getting the same value. Okay, so that is Kelvin or degree Celsius. On a peak sunny day, the difference between the maximum temperature and minimum temperature, that is called summer daily range. All these values we can change. Okay. The same way, winter and winter coincident wet bulb temperature. 11.1 in the winter time, 6.4. See, anyhow, we have to change this value. That is other story. But summer design temperature, the software is providing 43.9. Why 43.9 degrees Celsius? Sometimes in some location in Abu Dhabi might have reported with a temperature of like 49 degrees Celsius. Correct. That's a maximum reported temperature or a recorded temperature in Abu Dhabi. We will not be selecting the maximum recorded temperature in a particular area for our AC selection. This 49 degrees Celsius might have reported in the past year, but this temperature has not recorded everywhere in the Abu Dhabi. It has recorded in an isolated region, and this temperature might have existed for just 30 minutes or 1 hour. For just, this is very rare condition, and also this is not happening everywhere within the Abu Dhabi. So this maximum recorded temperature in a particular location, if you are considering for your AC selection, your calculation will be bulky. Your AC selection will be oversized. So your initial investment will be increasing. Your running cost will also increase. Then what temperature we should select? ASHRAE will be recommending, for example, summer design dry bulb temperature. If you're having doubt regarding any input, you can click inside the cell. After that, the function key F1. Function key F1 you can click. That will be guiding to the help. Not. So you can see summer coincident dry bulb, 0.4% design values are used. What is 0.4? It's simply nothing. See, anyhow, I'll explain that. This is like a 2001, this temperature is with respect to 2001 ASHRAE handbook only. As you know, due to the global warming, this is 20 years back report. Periodically, we have to update it, right? So this temperature might have already increased. So we have to change it. So I'll be going to 2009 ASHRAE handbook. Climate details 2009. In 2009, climate details, last pages. Here you can find the station. UAE, JK, LMNO, PQRSTU. For example, you are dealing with the UAE, Dubai. Okay. So we are dealing with Abu Dhabi, but in case if it is Dubai, this is the latitude of Dubai, longitude of Dubai, elevation, cooling dry bulb, or mean coincident wet bulb temperature. Mean coincident wet bulb temperature means when the cooling dry bulb temperature is a specific value, on that value, what might be the wet bulb temperature in the same time. Okay. Here they have proposed dry bulb temperature and mean coincident wet bulb temperature. Okay. Mean coincident wet bulb temperature, they have provided two values. Two values. How much it is? 42.8 and 23.8. There is, first one is dry bulb, the second one is wet bulb temperature. Actually, this is not the maximum wet bulb temperature recorded in that summer time. Maximum recorded, here we are getting 23.8. Maximum recorded wet bulb temperature will be this one, evaporation, 30.3. But this 30.3 will be happening when the dry bulb temperature was 34.9. On a seasonally, I don't know what month it is, but it might have happened. The maximum recorded wet bulb temperature is 30.3, but it has happened when the dry bulb temperature in the atmosphere was 34.9. But not this the condition we are designing. Because atmospheric maximum dry bulb temperature is 42.8. On that scenario, the wet bulb temperature was 23.8. This one we should select. Okay, that's why this one we are selecting. 0.4% means out of 365 days, just 0.4 days, this temperature will be existing. As I told, maximum recorded temperature in Abu Dhabi will be like a 50 degrees Celsius. That might be existing for just 1 hour or 2 hours. You don't want to select your AC machine for just 1 hour, 2 hour fluctuations. 0.4% of 365 means 1.46 days into 24. 1.46 days means 35 hours. This temperature will be continuously existing, not continuously. This 42.8 degrees Celsius will be existing overall 35 hours in an annum, 1 year. The same only.
Are we considering the future changes, future climate changes also during the calculation?
No. You can, but not that much fluctuations will come within 10 years and all. Anyhow, we will be updating this climate data with the 2021.
Okay. The changes are happening very fastly nowadays.
Anyhow, so, maximum 10 within 10 years, 0.8 degrees Celsius difference only will come due to the global warming. Maximum. Okay. 10 years, 0.8 degrees Celsius. Even that is also not 1 degree Celsius. Okay, so there is not huge fluctuation. Okay, so if you are selecting F1, 0.4% means about 35 hours during the year. Correct. So that you have to select. That will be the safe one. But 1% means not only 0.4%, they have given 1% value, 2% as well. 1% means out of 365, 3.65 days, this value will be existing. Dry bulb and wet bulb. 2% means out of 365 days, 7 point something days, this temperature will be existing. Which one you can select? Safest to decide is 0.4 only. So if you are selecting 0.4, the same, Abu Dhabi, 44.9 degrees Celsius and 23.2 degrees Celsius, that will be the dry bulb temperature and wet bulb temperature. But this is also 2009, no? Updated one you need. You can take that data from where? Climate data. You can simply Google it, ASHRAE climate data. You can go there. Any location, for example, we are having map option here, station option. Temperature 2009 onwards, it is there. Once in every 3 years, they are updating it. 2009, 2013, 2017. I need 2021 updated weather data. So not 2017, I'm selecting 2021. Okay, select 2021. If you're going to station, we are having Asia, North America, Latin America, Asia, you can select. Within Asia, where it is. Okay, you can go to UAE. Within UAE, you can select like Abu Dhabi International. Select Abu Dhabi International, you will be getting the climate data. Correct. Your cooling dry bulb temperature in 2009, it was how much? 2009, it was 42. Now, just most like within 10 years, big changes has happened. Exactly. (2021) when they are updating, let me go. Okay, 2021, the temperature was increased to how much? 0.4%. It has increased into 45.1 degrees Celsius. Nearly 2 degrees Celsius difference has happened within 12 years. Correct. As a thumb rule, 0.8 degrees Celsius within 10 years. 0.6 to 0.8. 45.1 degrees Celsius. This is like by stations you can find. By stations you can find. Instead of stations, if you're going to map option, map also, like within map option, you can search your location. For example, I'm staying in Trivandrum. Okay, you can type Trivandrum and Thiruvananthapuram. This one. Select. So you can find Thiruvananthapuram. This is my Thiruvananthapuram. Nearest stations also you'll be getting. So like within Thiruvananthapuram. When you are selecting this Thiruvananthapuram, okay, you'll be getting the climate data of Thiruvananthapuram below. So summer dry bulb temperature, you can see cooling dry bulb 33.9 only. Okay. because there's average. Normally, Trivandrum temperature less than 34 only we'll be designing it. From there, you can find it, update the data. Okay. Or suppose latitude and longitude, you can check. Latitude and longitude of Trivandrum, you can check this one. Control C. And you can come to here, climate data. Under the map session, you can click here. Here you can check your latitude and longitude. Okay. Enter. Here you can see National Library. This is like Keshavadasapuram, Trivandrum only. You can select this one. Okay. So if you are going to ASHRAE climate data, either from station or from map, you can find the updated one. Anyhow, we need what? Abu Dhabi, no? Abu Dhabi is already there. So Asia, under the stations, you can come to UAE, United Arab Emirates, Abu Dhabi International. This one. Which one? First one, cooling dry bulb. 0.4%. Dry bulb temperature is 45.1. Okay. Mean constant wet bulb temperature is 23. This one you should change. I'll be changing. Dry bulb is summer design dry bulb is 45.1. Before it was how much difference has come? 45.1, 43.9. 45.1 minus 43.9. Within 12 years, 1.2. Okay. 1.2 divided by 12 years. Divided by 12. Each year, 0.1 degrees Celsius. Each year, 0.1 degrees Celsius. So 10 year nearly 1 degree Celsius difference maximum in Abu Dhabi. Okay. So that's why that much huge difference will not come. Anyhow, 45.1, this one, 0.4%, 45.1. And summer constant wet bulb temperature, it was 23 before, now it was 23.3 before, now it is 23. Mean constant wet bulb temperature is 23. Summer daily range, hottest month, dry bulb range, this one. How much it is? 12.1. Before it was 12.8. Now it is 12.1. So what might be the minimum temperature? Maximum 45.1. So 45.1 minus 12.1. 12.1. So in a summer time, minimum will be 33, maximum 45. This 33 might be happening in the early morning. 12.1 on that time. Okay, anyhow, summer daily range we can give how much? 12.1. 12.1. Okay. Now the same like a heating dry bulb. Same like a 0.4, here it is 99.6, means 99.6% of time this might be the temperature. Within this atmospheric you have to design. So that one, 99.6 consideration. Winter design dry bulb temperature is 12. 12. What about winter coincident wet bulb temperature? Winter coincident wet bulb temperature, they have not provided here. Correct. They have not provided, but we can find from here. Psychrometric calculator is there. Okay. From this table, we can find whether you need SI or IP. We need SI. Okay. Because in the table, they have not provided winter, which one? Coincident wet bulb. Here we can find it. What's the pressure? Pressure is not uniform everywhere. Here you can see for Abu Dhabi, pressure is how much? 101. It is coming like a standard pressure 101. So this will be okay. You can keep the same 101. Not. Slight variations will come sometimes. So 101 decimal is not there, so that's why 101.00. So 101. You should. This is in kilopascal only. You should 000. This is a pressure 101.000. This is in kilopascal. You should multiply that with the 100,000. Okay. Now, altitude, height. Altitude is elevation. This one. How much it is? 27. 27 only. Okay, that is fine. You can keep that as 27. Now, dry bulb temperature in summertime, winter time. How much it is? Dry bulb temperature is 12. This one you can select. 12. So this I will be selecting. I need this value. Which one? Temperature, wet bulb temperature. But I should assume the relative humidity. Means this percentage is relative humidity. When the atmosphere is 12 degrees Celsius, what might be the relative humidity? Actually, there is normally it is not predictable much. Anyhow, as an average, the relative humidity, anyhow, it is not high, not less, as per our room requirement, let's say 50%. We are giving this value, enter, you can find the wet bulb temperature in the summertime. Here you can see how much it is. 50%, it is not too high, too less, as an average. Relative humidity, when the atmospheric was 12 degrees Celsius of temperature, I'm assuming 50% relative humidity. Then the wet bulb temperature, how much we are getting? This one. 7.2. That one you can consider here. Winter constant wet bulb temperature is 7.2. Okay. Click OK. Save it. Now our input is proper. Accurate. Correct. So that's why. Now you can see that it is not as per any 2001 handbook or something, because user modified, accurate, updated data. Okay. Only this thing you have to do, then you can do your project. No problem. Okay. Anyhow, but remaining other things are also there, we can discuss. Atmospheric clearance number. Atmospheric clearance number is having a role for solar radiation from the sun. The atmosphere is so much cloudy, means a lot of clouds are there. See the value, you can click here, F1, you can find 0.81, 0.85, correct. 0.8 for hazy condition, 1 for normal, typical condition, 1.15 for very clear condition. Why that is? Because if it is too cloudy, clouds will be preventing like some solar, correct. So cloudy environment and all, you can consider this is 0.85. But if it is a very clear sky, then you can consider 1.15. Normal condition, you can consider 1. Okay. The next one, average ground reflectance, 0.2 you can use, irrespective of the material. Why it is? Because this is your building and this is your ground. So the solar heat or solar radiation will be hitting on the ground level, and after that it will be reflecting and hitting on the building side walls. So by floor radiation, means floor reflection also, the building objects might be getting the heat. But with respect to the type of material we are having on the floor, the absorption reflection value will be varying. So that's why average they are considering 0.2. But if you are going there, new concrete 0.31 to 0.34, old concrete 0.2 to 0.2, bitumen normal tool and bitumen parking lot and all 0.09 to 0.12. But 0.2 normally for old concrete or crushed rock and all, no, that's a condition. Rock interlock and all, 0.2 is more than 5. Okay, ground reflectance. Soil conductivity. Why soil conductivity is important? If you are designing anything on the basement. So this is soil only. So how much solar heat might be entering into through the soil? How much heat might be transmitted? Means like it will be infiltrating through the or percolating through the soil. Then it is entering inside. To calculate the soil heat gain through the basement floor, the software need is soil conductivity. Okay. Now, this soil conductivity 1.385 you can select, or if you want to change it, you can go to F1 and you can change it. With respect to the type of material, sand, slits, clay, loam, different material, the value will be varying. Okay, from here you can take it. Anyhow, normal sand, it is 1.45, between 0.35 to 1.45. That's why they are considering as an average 1.385. Average. Now, design calculations month. Means, suppose if you want to calculate only summer. Summer, suppose if I'm designing in India, summer might be coming on when, let's say March to July. So I need to calculate between only March to July. Other month you can neglect. But it will be good if you are selecting January to December. 12 months. Means January to December, the software will be calculating. The time zone, Greenwich Meridian time is -4 with respect to the GMT. That is, with respect to the Greenwich Meridian time, that is 4 hours less only. Where? Abu Dhabi. Okay. Daylight saving time. Daylight saving time, it is not mandatory. Why it is important? Actually, this is important for energy simulation. Means AC machine might be in some countries, especially in special like April month to October, sometimes depends on some country. Instead of 12 hours, they might be getting 13-hour, 14-hour solar, means day. Even night at 10 also, sometimes in Russia and all, a lot of spaces it is there. No? Even in night at 10 also, it might be too, like skylight will be there. That's when that scenario in some country, instead of 12 hours, Daylight, they might be adding 1 hour more. Instead of 12, they will be considering 13 hours. So accordingly, only they will be working it, the time, everything they will be managing. So if the daylight or if the working hours are increasing to 1 hour extra, or the daytime is increasing 1 hour, working time will not exceed. But daytime is only exceeding 1 hour extra means, accordingly, AC machine also will be working. No, so it will be consuming extra 1 hour energy. That's why this daylight saving time, from which time to which month to which time, the daylight saving time, which month it is starting, April, when it is finishing. Anyhow, it's not mandatory. You can avoid it. Okay, that is our design parameters. All the other 3 regions, these are for our references only. Anyhow, in Abu Dhabi, maximum heat gain is happening on which month? July. Here you can see. Here you can see how much it is, 45.1. 45.1, if you want to change that into 48, click OK. Again, you can go to design temperature. See, manually you can edit it. Okay, but what temperature you have provided here? Summer design dry bulb temperature 45.1 you have provided there. But even if you want to edit it, you can. Manually you can edit it. But otherwise, if you're not editing, means automatically what value you have provided here, the same value will be reflecting. So in Abu Dhabi, peak atmospheric condition will come on July and August, 45.1 and 33. Dry bulb temperature and wet bulb temperature, you can find maximum value, minimum value. This is monthly details. Monthly maximum, monthly minimum. Hourly details. For example, January 0000, what is 12 AM, 1 AM to 23. 24-hour schedule. Last. 24-hour details we are having there until 23. Correct. Maximum peak gain is happening on July and August. So January dry bulb, January wet bulb. February dry bulb, February wet bulb. We can come to July and August. July dry bulb. On what month, on what time this will come? 45.1. Normally, everywhere, between 3 PM to 5 PM. 3, 4 or 5. That's common. Can check on what time 45.5 is coming on. What time? 15. 15. Okay. How much it is? 15 means 3 PM. 3 PM only will be happening. One thing. See, we will be assigning the working schedule of the office. Suppose if you are designing a space, on what time the space will be working, when the people will be leaving, we'll be assigning schedule. For example, I'm designing a building. The working time of building will be from 8 AM to 2 PM. Abu Dhabi only. But my office will be working from 8 AM to 2 PM only. So this is 8 AM, 8 AM, and this is 2 PM, 14. Between this, what is the maximum temperature? 44.7 degree. But if you are considering 24 hours under this July, 45.1 degrees Celsius is the maximum. But that is happening on 3 PM. But my office is not working on 3 PM, right? My office will be closing on 2 PM only. That's why, as per the schedule that you are assigning, if the space is not functioning on the peak time, the software will not consider this 45.1. Rather, within the working time of the building, what is the maximum temperature? 44.7 degrees Celsius, the software will consider. Accordingly, only the software will be generating the report. Manual calculation, these kind of adjustments are very difficult. Correct. That's why, since the software is having the temperature details with respect to the hourly detail, the accuracy of the design will be good. Optimized design, energy efficient design, the software will perform. So that's why the software will not, even if you are giving the maximum input or maximum temperature input, the software will not consider that temperature always. Rather, with respect to the schedule that you're assigning, on that time period, what is the maximum temperature? Accordingly, the software will be designing it. Correct. That's why we used to call that as hourly analysis program. Since the software is having the data with respect to the hourly detail, we used to call that as hourly analysis program. Okay. Revit and all, we are having this heating and cooling load calculation analysis option, but the output that we are getting from the Revit is not proper. So when we are doing the calculations in Revit, all the spaces we will be converting into a format called GBXML, Green Building XML. Then we will be uploading into third-party analysis softwares like HAP, Trace 700, different softwares are there. Then we can analyze. Comparing to all the other spaces, other softwares, HAP is good. It is having good accuracy. Okay. Fine. Anyhow, these temperatures are editable. If the client is asking to edit the temperature in this, you can. Okay. Now your design temperature, design solar. Design solar means, suppose in north direction in July month, how much solar heat will get? Suppose if you are having a building, this building side is exposing to northeast direction, this side. For each meter square, how much solar heat? Unit you can check watt per meter square. So northeast direction, which month we are getting the maximum value? Northeast direction, the maximum value will be getting on this 572.5. That is happening on which month? June only. June. So solar heat gain is happening on June, northeast direction. With respect to the direction, it will vary. How much each meter square? If you are considering 1 meter by 1 meter area, each meter square 572.5 will come. 572.5. Okay. So suppose if it is 10 meter by 10 meter area, 572.5. 572.5 into 10 into 10, how much it is? 100. Accordingly, the overall total heat gain, the software will be considered. But if you want to consider something extra, correct. And this is horizontal. These are with respect to the direction only. North direction, northeast direction, because inclined one. Inclined. Anyhow, this value will be varying with respect to the angle of inclination as well, but that is negligible. But horizontal surface, how much? If you are designing a roof will be horizontal only. No, horizontal surface, how much? Horizontal surface from roof and all, you can see from here. Which month maximum horizontal solar heat gain? Maximum we will be getting in 890. April month, horizontal heat gain will be maximum. Okay. But if you, any value, if you want to slightly consider 20% or 10% more, here we are having a term called the multiplier. So this multiplier, if you are considering 1.2, accordingly, all the values the software will be considering in the final report. Okay. Multiplier means when you are selecting this value, 10% or 20% if you want to consider multiplier. 20% means 1.2. Now it is 1 only, you can keep that. Simulation, I will come. Simulation, I will come. Okay. When we are doing the schedule, I will come to the simulation. Okay. Now you can right click this one. Just go to the properties of temperature once again. If you want to check that, you can adjust it once again. Okay. Okay. Fine. Now that is your weather property. The profile you can change from here like different. Yes. Okay. So we did weather property. Now we can go to the spaces. Weather property. Fine. Middle East, UAE, Abu Dhabi. All the values we have assigned. Now I'm just going to the spaces. We have to give space input for this training room 1. I'll be giving the input of this training room 1. Okay. Create the space. To create the space, you can come to the space option. You can come here, double click and open it. So you'll be getting a space properties tab. In that we are having general, internal details, walls, windows and doors, roof and skylight, infiltration, floors and partition. All these inputs we should come. Okay. The first one we can start with the general. In general, we have to assign the name of space, the floor area of space, average ceiling height of space, building weight of space, then outside air ventilation requirements. Okay. The first one, anyhow, let me give the name of space. What is that? Training room 1. Floor area. Just click OK. Floor area. See, for your, we have not discussed AutoCAD. So anyhow, you'll study that. Don't worry. I'm just taking the area of this training room board. Okay, I'll be taking from here. These columns and all you can avoid. What is this one? This one, actually, you can check the width of this one. This is just 500 mm. 515. 50 centimeter. It is not stair. Stair means at least 900 or 800 to 900 it should come. 3 feet. 500 mm, it is not possible to walk. Actually, this is wardrobe only. Wardrobe, correct. To store the files and all, that's. Let me take the area of this one. This drawing has made in what unit? This drawing had made in millimeter only. Millimeter. That's why just go to the measure option. I'm calculating the area. Okay. So I'll be selecting from here. I'll be going here. Columns I'm avoiding. I need just a floor area. Then until there, I will be extending until here. Then up to here. Then I can go until the wall straightly. Then I can go here. This minute projections and all you can neglect, no problem. So even this is also, if you want, you can neglect, but let me take it. That one you can avoid like this. Even if you are taking straight, it's not a big issue. This is my floor area. Enter. Area, how much? This you can see. Actually, this value with respect to the millimeter square only. Millimeter square into 10 raised to minus 6 or millimeter square divided by 10 raised to 6. We can find that in meter square. So 1, 2, 3, 4, 5, 6. 77.79 square meter. 77.79 square meter. That's an accurate floor area. 77.79 square meter. 77.8. But you can take like this as well. From here to here. But that is not accurate. From here to here, how much it is? 10.86. Then from internal, from here to here, how much it is? 7.91. Correct. This is millimeter only divided by 1000. 10.086 into 7.9. 7.917. Area will be 79.85. But it is slightly more than 77.8, right? We got 77.8 only. Because we have avoided these columns and all. That's why. Okay. So let me mark that. I'll be considering this, but this is not accurate. That's the only reason. So floor area, I'm assigning how much floor area? 77.8. Okay. Now, third value is average ceiling height. Ceiling height. We know, just remember this. The floor in which we are standing. The floor in which we are standing, this is called a finished floor level, tile surface level. The drawings will be marking. With respect to the finished floor level only, we will be marking the height of services and all to avoid the clashes. Finished floor level or FFL. Top side we'll be having slab. Let's say this is bottom of slab and this is top of slab. I will give you the section of this one, this project. Anyhow, if you're not having any false ceiling, your ceiling height is this one. Means with respect to the finished floor level to bottom of slab. That's your ceiling height. This one. But in between bottom of slab and finished floor level, here we will be having another layer. No, that is your false ceiling level. Normally, this height as a standard is 2.7 meter or 2,700 millimeter. At least 2.6 it should come. Because an average height of a human is 1.8 meter. When he's raising his hand, it will come 2.4 meter. So it should not touch the false ceiling, right? So 2.6 meter, at least it should come as a standard. Normally, almost all the building 2.7 meter we will be having. Between this region only, we'll be taking all the services. So this average ceiling height, the software is not using to calculate any wall area, nothing. Average ceiling height, the software is calculating for infiltration calculation. Means volume. Because if you want to calculate the infiltration calculation, we need building volume. So what the software will do? Software will be calculating the floor area, multiplying floor area into average ceiling height. Accordingly, the software will be calculating the volume of the space. Then it can calculate the infiltration rate. We can study infiltration. Okay. Okay. So if you're not having false ceiling, this is your ceiling height. If you're having false ceiling, up to the false ceiling. Then why it is average ceiling height? Ceiling will not be uniform always, right? Sometimes, if this is your space, stepped ceiling can also come like this. Ceiling will be like this. So from here to here, this is height 1. Then from here to here, that is height 2. Sometimes it might be curvy. Then from the center point to that, you can consider height 1. Okay. Height 2, this height 2. Then this will be height 3. So average ceiling height will be ceiling height, because one value you need now. All the 3 values you can't provide there. So your ceiling height will be h1 plus h2 plus h3 divided by what height? 1, 2, 3. So you will be calculating the average ceiling height that you can provide here. That's why we used to call that as what height? Average ceiling height. Clear? Okay. Anyhow, in our project, this project, finished floor level to the bottom of slab. In this floor, first floor, here we are having 3.9 meter. 3.9 meter. And this is 2.7 meter only. So overall 2.7 minus 3.9. Here we will be having 1.2 meter of false ceiling. 1.2 meter. We can consider that 1.2 meter. Accordingly, we can decide. Clear? Okay. So anyhow, here what average ceiling height, how much we can give? Straight ceiling only we are. Ceiling drawing I will give you. This reflected ceiling plan, RCP of this project. Reflected ceiling plan of this project is this. This is a false ceiling layout. You can study. I will explain this. Okay. This is your false ceiling. Anyhow, height we are having 2.7 meter only. So I'll be giving 2.7. Building weight. Building weight is a structural term. It's not an MEP term. But for MEP, it's not that much important. But even though you should know what is this value. Anyhow, if you are moving this one, this value will be decreasing. If you are increasing this one, this will be increasing. Building weight. Unit you can check kilogram per meter square. Correct. So for example, if you are having a building, the weight area of the building, let's say floor area, this is 10 meter by 10 meter example. So floor area is 100 meter square. The weight of the building, including everything, structural load and all, if it is coming like a 20,000 kilogram, 20 ton, then 20,000 kilogram divided by floor area, 100 meter square, you'll be getting 200 kilogram per meter square. Each meter square of building weight is nearly 200 kilogram. That is this unit. Light building means if the wall thickness is more, your concrete thickness is more, floor thickness is more, means building structural combination is bulky, the building weight will increase. Why it is important? See, this building material in the daytime, normally, the building material will be getting heat from the outside. In summertime, I am saying heat from the outside. The building material itself will be holding some heat. Then eventually in the night time, it will be dissipating the heat to the surroundings. That heat is called the diffusion heat. Heat will be, building material will be holding the heat in the daytime whenever it is getting the heat, because it is having that much volume in it. Eventually in the night time, when the surroundings are less than the wall temperature or the roof temperature, this material will be dissipating this heat to the surroundings. So that's why if your building is bulky, it will be, the building is less. Wall thickness, everything is less. Suddenly it will become heats up. Suddenly it will be ejecting to the surroundings. Suddenly it will cool. If your building is bulky, slowly only the heat will be entering inside. Initially the wall material will prevent it. But slowly only it will become cool. It will take some time because it will be holding a lot of heat. That's why if the building weight is increasing, the structural building weight is increasing, accordingly, the holding capacity of the heat for the building material will be increasing. Anyhow, 341 or 340, you can consider the average. You don't want to change it. If you don't know the light details or the heavy details or the medium details, you can consider that as building 341.8 kilogram per meter square. Actually, this building weight data we are getting from where? We are getting this data from the structural team only. Okay, but you can keep this one, whatever the building is. There. The next one, outside air ventilation requirement. See, normally when we are doing the heating and the cooling load calculation, a lot of consideration. What are things we should consider? The first one, heat gain through walls, then heat gains through a roof, heat gain through floor, heat gain through ceiling, heat gain through door, heat gain through window, heat gain dissipated by people, then lights fitting, lights will be there, power equipments, electrical equipments. Okay. Then we'll be having ventilation. Then we'll be having infiltration. Power equipments, kitchen equipments will also come there. Kitchen, ventilation, infiltration. Then we'll be having partition. Kitchen equipment, you can consider below the power equipments. If it is only sensible, we can study that. Then the last one is miscellaneous. Anything other than this 12 is called miscellaneous. Out of this 13 condition, whenever we are directly dealing with the atmospheric air calculation, there moisture, we are dealing with the moist air, there what we have to do? Psychrometric calculation. But the software will do that. We have studied that psychrometry. Problem also we have performed. Here you can see these two things, ventilation and infiltration. Ventilation means to maintain the indoor air quality. From outside, we have to take hot atmospheric oxygen-rich air that we have to treat it. We can't directly provide within the space, right? We have to cool the air, then we have to introduce it. Intentionally, we are doing. That is called ventilation. So this outside air ventilation requirements, normally we have to give this input as ventilation. Either we can give the ventilation flow rate in liter per second, or we can give the ventilation flow rate in liter per second per meter square. Sorry, this as per ASHRAE 62.1. ASHRAE 62.1, either by liter per second or this air changes ACPH calculation also it is possible. 2-3 methods are there to calculate. Anyway, as per ASHRAE, normally for comfort air conditioning building, we'll be following this one, 62.1 standard only. Based on that only, we'll be calculating it. Manually, we can calculate. Okay. Or the software can also do that for you. But how we have to calculate manually, I will explain that. Okay. That is ventilation. Infiltration means doors will be having cracks and undercut. Whenever a person is going outside, he will open the door and he will close it. Walls will be having cracks. All through regions, the hot atmospheric air will be entering within the space. Conditional. The space is pressurized, that can prevent. We can discuss that. That's why if air is infiltrating inside, that is called infiltration. So whenever that is infiltrating inside, it is carrying sensible heat and latent heat from the atmosphere, plus contaminations as well. That's why whenever we are dealing with this ventilation and infiltration, we have to do the psychrometric calculations. But the software will do that for you. Next step, outside air ventilation requirement is ventilation. How much fresh air has to be introduced within the space, that we have to give input. That one we can discuss in the next class. Next session, you will be studying that. Okay. Now you can ask your doubts. If you are having any doubts, I will be clearing it.
So in this design temperature and design solar and all these things is there, no?
Besides solar.
Yeah, that one we need to select or it will come automatically.
Preset value only. Design solar values are preset only. You don't want to select it.
Okay, okay. Yeah.
Okay, then